Thanks for staying with us. I'm Sarah McIntyre, filling in for Jerry Agar, and we're going to keep the regular Friday segment he does, Beyond the Sun. We've got our two science guys in studio to talk about the latest. We've got Jesse Rogerson, who is I just called you a scientist, smarty pants, but you're actually a PhD candidate at York University. Thanks for coming in. And of course, Harrison Reese, who's our Sun News contributor, webroom guy. What is happening in the great big beyond? Any news?
Oh, there's always news. I mean, every week we got good stuff, and this week is big week for Mars. So Mars at this moment has a bunch of different instruments either roving or orbiting the planet, and the big one is the Mars Science Laboratory, as many people know it, Curiosity.
Right.
And just this week, there's a huge press release, a big scientific discovery of methane on Mars.
What does that mean?
Great question. Great question. Now we've already
we know what it means.
I know. Does it mean that men are from Mars? Because that's what I always say.
The jury's still out on that one, so we're still working on that
one.
But we'll let you know if anything changes. So methane on Mars. Now, to be fair here, methane has been measured on Mars before, but this is the first time it's been measured on the ground with a scientific instrument called SAM, the sample analyzer at Mars. So it's the first time it was discovered on the ground, and the key thing about this here is that methane can be created in two ways: water interacting with olivine, or
which is a kind of rock.
Which is a rock.
Okay,
yes.
thank you. Thanks for the close notes there. This is, you got to dumb it down for me here. I'm not a science girl.
But here's the good one. The other way is microbes.
Okay.
So we have two possible ways.
So what you see on the screen here, down on the very bottom there, underneath the surface of Mars, you see that there's either microbes producing methane or water interacting with olivine, the kind of rock.
So what are microbes?
Like bacteria.
So like life?
Life, exactly.
Life. Oh, okay. And so we may have life on Mars?
Maybe. And that's the big thing here. The interesting thing in what's been detected in the big announcement this week was that Curiosity detected spikes in methane, the level of methane on the planet. So there's always a sort of background amount of methane in the Martian atmosphere. But in the last few months, there's been spikes, tenfold spikes in the amount of methane being detected. And so something is producing this methane, or at least releasing this methane on Mars
dynamically,
presently, right now. And so it could be just this chemical process with rocks happening underneath the surface and it's getting out. Or it could be something else.
Now, is Mars a planet where there is speculation that there used to be life and now there's not life? Or is it that it's going to have life eventually?
That's one of the big questions. Curiosity's main mission was to figure out if the conditions on Mars were ever in the past such that it could have supported life. Was there water? Was the temperature favorable? Was the water neutral, or was it acidic, or this sort of thing? And so it's answered a number of those questions that they believe now Mars could have in the past supported life.
And was there water on Mars as well?
Yes. Seems like it.
Yeah, there was water on Mars. There were stable lakes. Like where Curiosity's roving around right now, where we're seeing some of those pictures of, is something that was for tens of millions of years a lake on Mars around this mountain, Mount Sharp, which is what it's now sort of slowly going up the side of.
But there's no evidence of bones or decaying material or anything like that.
No. There's no fossils, and there's no present or past evidence of life itself, but the conditions were favorable for life.
So there's lots of questions, because there's
Can we live on Mars then?
No.
Can I send you guys to Mars? Or?
No. I mean, sure.
If you have the budget for it, let us know.
I don't. Seriously.
Yeah, no, what life needs is a number of things. Water is one of them, but there's other things in terms of an atmosphere that protects you from radiation from the sun. There's a stable environment for a long time, because life is complicated. It's not something necessarily that just pops up in 6 months. You need, tens, perhaps hundreds, or a billion years for this sort of chemistry to happen. And even if all these conditions are right, life may still not happen.
Right.
So the question has not been answered for Mars by any means, but Curiosity is starting to fill in some of the puzzle pieces to be able to answer this question. And then future missions will more directly try to answer the question, was there life there? Not just were the conditions right, but was there actually life there? And then perhaps maybe deep down under the soil today, where maybe there's still some liquid water, could there still be any life surviving there today?
And that's where the microbes come in, and the methane, right?
Yeah, so the methane has just been found, or confirmed, dynamically spiking up and down. So they're just going to start following that and seeing what's causing that methane to be released, and that could lead to life.
Are they going to drill down at all? Does it have the capacity to do that, to see what's below the surface?
Curiosity has a little drill, so it can drill into rocks a little bit to see what's in them, to see what materials are in it, what it's made of. It can scoop up the dust, the powder from its drilling, and analyze that, but it's not going to have the capacity to go down any particular depth. one that's planned, it's the InSight mission that's planned for 2018, I believe, is one that's going to be more focused on drilling down into the surface.
Okay, so that's all about Mars, where men are from. We're going to take a quick break, and I think we've got a couple of other planets to run through to give you some updates on the Beyond the Sun segment coming up next. Thanks for staying with us. I'm Sarah McIntyre, filling in for Jerry Agar, and we're doing the Beyond the Sun segment. We just talked about Mars. Now we're going to go to where women are from, Venus. What's happening with Venus? Is she hot? Is she dancing? What's going on?
Venus is always hot. It's the hottest planet in the solar system. It's 450 degrees Celsius on the surface all the time. Yeah. But
sizzling.
Oh, no idea. It's like inside of an oven or worse. But we're here to talk about because there was a spacecraft orbiting Venus for the last 8 years, taking data on Venus, around Venus, and it has just turned off. Unfortunately,
it's run out of fuel after 8 years. This is the Venus. Yeah, this is it. That's an artist's impression of Venus Express that's been mainly studying the atmosphere of Venus for the last 8 years, but it's just run out of fuel. And
but were we able to get any? Was it sending the data back? It was collecting remotely. Okay, so it can be left out into the atmosphere.
It will burn up in the atmosphere in the coming weeks because they've actually been doing with it some pretty daring maneuvers because it accomplished most of its mission. So they tried to do something a little risky, and that's where they started to dip it down into the upper reaches of the atmosphere on Venus to try to collect some data from there. So in doing that, they burned a whole bunch of the fuel. They've now run out of it, so it will burn up in the atmosphere, but it's collected incredible data over its 8-year mission. It was certainly very much a success. Learned a lot about Venus, the atmosphere, and an interesting discovery down on the surface as well. This one helped to figure out that there may still be active volcanoes on the surface of Venus. Either very recently meaning millions of years, or perhaps presently.
Well, this is the interesting thing I always wonder. So this was done with the European Space Agency.
That's correct.
And we're all familiar with NASA, which is the American. So what's the level of cooperation between these agencies? So the European one, I'm assuming, is funded by European taxpayers. The American one's funded by the Americans. Do they share data?
And the Canadian one is funded by Canadian taxpayers. And yes, they're all very cooperative. The best example of that is the International Space Station, where there's 14 space agencies all cooperating to make it function on a day-to-day basis, where there's 6 people living right now. And the Canadian Space Agency is a big part of that, as is NASA, as is the European Space Agency, and even the Russian Federal Space Agency as well.
For instance, on Curiosity, as we were talking about before, there are instruments that were built in Canada on the Curiosity mission.
On Mars. It's a robotic arm that is out there digging into the surface as a Canadian
Canada arm, yes, we're all very familiar with that.
Canadarm's the one that's on the International Space Station. This is sort of a small version of that, but certainly another piece of Canadian hardware.
Okay, so Venus is hot. We know she's hot. Mars has got some methane. What else is happening in their solar system?
It's a cold spot.
This is the one that I'm really excited about. This is the New Horizons mission. So it's a satellite. It's a spacecraft that we launched 15 years ago.
2006.
14. Oh, not as long.
Oh, that's when the Conservatives formed government.
There you go.
Yeah, I remember that.
So that's a marker I didn't know.
Okay.
And it's heading to Pluto. Everybody's favorite Pluto. This is the one, object, I'm going to say object, in the solar system that we haven't explored yet. Every single planet we've explored with a satellite except for Pluto.
No, but is Pluto a planet, or did it get delisted? It's not.
It is not
part
a
of
planet.
Yeah.
I will take a stand here, Jesse. You're trying to be PC. I will take a stand. It is not a Pluto.
So
it is not a planet.
It is not defined as a planet.
Okay, so is it a star or what?
No,
it's called a dwarf planet.
A dwarf planet.
It's a round object in space orbiting the sun. That's good enough. And we've never visited it. It's got 5 moons. The best images we have come from the Hubble Space Telescope, which orbits Earth. So this mission, the New Horizons mission, is going to be the first of its kind to see detailed images here. This is what we see now of Pluto. That's our best image of Pluto.
That's
right
it. It looks kind of blurry.
Exactly. So we're going to get some high resolution stuff of the surface of Pluto.
So why it's in the news right now is that New Horizons, for most of its journey out to Pluto, has been asleep because it's not really doing much. So they try to preserve the instruments and the technology in it by shutting it all down. But it's now, in just this week, woken up, getting ready for its arrival at Pluto. That's going to happen. It's still a ways away. It's going to happen in July this summer.
So it took 8 years to get to Pluto.
Yep. And traveling 5 billion kilometers.
Yeah, and New Horizons is the fastest spaceship that humanity has ever launched.
Wow.
Ever. Bar none, it is going faster than anything we've built.
And now, was that a NASA, European Space Agency?
It's a NASA.
It's a
American
NASA. Okay, and so it's gonna start sending some data back to NASA, and we don't expect that till when?
Well, it is already sending data back. It's taken some pictures along the route as it's gotten closer and closer to Pluto. It took an image that showed distinctly Pluto and Charon, Pluto's largest moon, as distinct objects, which is something that no spacecraft has been able to do before. But it's going to be sending more and more as it gets closer and closer to Pluto.
Excellent. Well, I'm up to speed. I feel very sciencey now.
Good.
I can talk about the planets later tonight. So thanks so much for coming in studio for the Beyond the Sun segment. We're going to take a quick break, and then we're going to talk to David Menzies and Glenn Foster about some sticky situations. Stay with us.